Alright folks, the next thing we're going to take a look at are while loops. And while loops are going to be incredibly important tools for you to be able to repeat code inside your program. Okay, so if you want to make any sort of program that you want to have a repeat condition over and over again, maybe ask the same question over and over again, check for the same condition over and over again, there's or you want to check to see if something hasn't happened yet. Maybe a person hasn't entered a password yet, so you want to keep on looking for the prompt or something like that. A while loop is going to be the key to doing that. Okay, so a while loop is going to run while a condition is true or not true. All right, so whether a condition is true or false, you can set the condition however you want, and we can repeat that set of code over and over again. Okay. To make this really simple, all right, what we're going to do is we're going to set up a simple program that mimics a young kid asking you over and over again why. All right. So what we're going to do is we're going to set up a little demonstration that's going to show you very simply how a while loop works. All right. So the first thing is let's set up the name of our program. We can just do Annoying Child Simulator. And what this is going to do, let's do print. I am a annoying child. And for this one, what we'll do is we can set up a person's initial response. What the program do is basically have the program ask why over and over and over and over again. Okay, and what it's looking for is a keyword to try to stop it. So initially, we'll set the person's response to be equal to nothing at all. Actually, just a pair of quotes. And what that does is it sets up the initial variable. And then we set it to be nothing at first, and we'll show you why we do that in a second here. And then we can do while response is not equal to because. Okay, what we're doing here is just setting up while response does not equal because. So what? Right now it equals nothing, and so this is going to run until this actually becomes because. We put a colon there. Okay, and then we say we execute the code that we want to run as a result of that. So we can do response equals input y. Okay, so while response is not because, make response get the input of y. Basically ask y over and over again and wait for a response. Now we see that this is going to run because right now a response does not equal anything. Okay, but there will be a pause here while it waits for the response. It's not going to just skip over the response and like execute back over and over again, right? There's going to be a loop, right? So it's going to continue in a circle. But it's not going to go back to line 6, the while response is not equal, because until it executes line 7, which is response equals input y. So it's going to wait for a response. So we click run and we'll see that happen. I'm an annoying child. Why? I don't know. Why? Sigh. Why? Okay, so we get the point here. Just keep on asking why. And then what happens if we enter because? Okay, well nothing happens, but we notice that little white, the yellow arrow appears, and that shows us that the program has stopped running. So we can do something afterwards. We can do print oh. Let's run it again. I know a child. Why? Because. Oh. So we can make this continue on and on, right, for as long as we want. The user won't actually know why this is just running and what keyword they need to break out of the loop. But why did all of a sudden line 9 print when we entered because? The computer is going to execute the code from top down, right? And meaning sequentially, right? So it's going to go through line by line. And what happened is a while loop is going to run while that condition, while whatever condition you set here is true. So while response is not because, okay, it will execute line 7, which is over and over and over again. It'll ask for an input y. And we save that input as response. Okay, so we're actually overriding the response here. Okay, and then what ends up happening is that as we overwrite line 5's response, okay, it does a check again while response is not. Well, we change response every single time we run this code on line 7. So eventually, if we enter the right word, if we enter the sort of the key phrase here, the key to stopping this whole thing, because this while loop will stop executing because the condition is now false, right? While response is because, okay, it stops executing both lines 6 and 7 and jumps down to the next line of the program, which is going to be print. And it's going to be print O. So whatever happens exactly after this while loop is going to happen next. And in this case, it's going to be a print statement for because. Okay. Now, the next thing is that we need to talk about why we set up this response here in the first place. Okay, and oops, get my JavaScript mixed up. We call this a sentry variable, or something like a check. All right, and the reason we do that is because what if we just set up while response is not because input response on and on and on. Okay, what ends up happening is that there's nothing to stop this while loop. So when you code in your while loops, you have to make sure that there's some way that you can control that, because if we don't control it, okay, it's going to have an infinite loop or a runaway loop. And here we want to create that variable, that sentry variable. Most of the time we create it right before the loop itself. Okay, it's a pretty good idea to set up your response loop with some type of empty variable. So if it's a number, maybe 0, or maybe nothing at all, or a response being here an empty, just an empty string. Okay. We want to make sure that it's possible for the while loop to evaluate to true at some point, right? The block will otherwise the block will never run. Okay. If we were going to make a modification to this, right, and say up here, what if we did because response equals because, while response is not because, execute y. I'm going to clear out that execution there, and I'm going to click run, and it just goes I'm an annoying child and oh. So we see that if we set the initial condition to be the condition it's looking for, this is not going to run. So by leaving it blank, we allow it to actually run in the first place. Now, the next thing is that we need to have some way of updating that condition. So we have to have some way of updating this to make sure that we control the number of times the loop runs. So that's what we do on line 9 here. Okay, is we're controlling the number of times it runs based upon this response input. Okay, another way you could do it, we can say controlling the sentry variable. And what we can do is we could do something like counter equals 0, while counter is less than 10, print counter. Or print, yeah, we could do print counter. Let's go print up the numbers. Okay, so let's, I'm going to take all this here. I'm going to comment this out so it doesn't run. I'm just going to do that by doing control or command /. Okay, so now we have here, we have a simple program. Okay, and what did it do? Ah, I know what it did. So actually, I did the thing that I was just warning about, which is going to be, okay, we have a counter equals to 0. While counter is less than 10, print counter. And what's it doing? It's just printing a bunch of zeros, a lot of zeros. Okay, and why is it doing that? Well, we provided no way of actually updating that counter, right? So we had no way of actually, we created what's called an infinite loop, okay? And what it's going to do is going to print 0 forever. We provided no way of updating that total, okay? We can do that actually by after each counter, we can actually add in a statement here that does counter equals counter plus 1. Okay, so it takes that counter variable. Remember that assignments happen right to left. Okay, so here counter will get executed first. Counter plus 1, so we'll take 0, add 1 to it, assign it to counter, back to counter. So counter just basically gets a plus 1 version of itself. And then it goes through the counter and it does a check for that as well. And so let's run it again and see if that solved our infinite loop problem. Okay, we see it did. I'll write a little note here, infinite loop. Okay, and we could say added to prevent infinite loop. Okay, you see here it's going through, it's just printing through each counter all the way up to 10. Now if we change this number here, 20, what we do is we change the limit we're looking to go to. We can change that control. We run it, it goes all the way up to 19. Pretty cool. All right. So this is while loops. They are incredibly useful, incredibly helpful, and incredibly important to programming. Okay, we have to be able to repeat code over and over again. We don't have to write code, the same code over and over again. So we use while loops to repeat that code for us, and then we use a century variable, like the counter here, to watch over that while loop to make sure that it's doing what it's supposed to do. And then we have to have some way of inside that loop of modifying or changing or updating that counter variable, that century variable, to make sure it's aware of the most recent state of the program, to make sure it knows how many times the loop has happened. And essentially that's all this is doing, is just updating that century variable to let it know how many times the loop has happened, so the century variable knows to shut it down when you need it to. Now there's some cases that maybe you want it to run over and over again. For instance, a very simple program is running things like as like stoplights, traffic lights. You don't want that to run 1,000 times and shut down and have to call out a technician to go out there and type in the new number of times you want this thing to run. So as long as you know that you want your program to run infinitely, okay, there's nothing necessarily wrong with an infinite loop. Okay, there's nothing wrong with it. And in fact, there's many cases in programming where it's very helpful and useful. But for us, at just beginning, it's more likely that you're going to design a while loop that you didn't mean to become an infinite loop. And in that case, this shows you how you can control it.